Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over transformed quadratic functions presented in vertex or standard form. The instructions for the problem we're going to be doing are as follows. We're to find the vertex for the given quadratic function after identifying the form. We are to describe the opening, find the extrema, value, and where it occurs. We have to find the axis of symmetry, describe the shifts, then make a table of values using points about the vertex and also the y-intercept point. And then we're to then graph the function and label completely. So let's assume that for question number 1, we have the quadratic function y equals negative 3x plus 1 square minus 5. Okay, so we'll start out by identifying the form of the quadratic that this is given in. This quadratic is in vertex form. Some textbooks refer to this as the standard form also. Okay, so you can refer to this as the vertex or standard form of the equation of a quadratic. Alright, now, first part we have to find the vertex. To find the vertex, what we're going to need is we're going to need to make use of the values of h and k. That's the vertex. So let's write down the formula that will enable us to determine what h and k are. So we're going to write down the formula for the vertex form of all quadratic functions. Y equals ax minus h quantity square plus k. Alright, now let's place the equation under consideration underneath the formula and then see what's the value of h and k are. Alright, so the problem we're dealing with is y equals negative 3 times x plus 1 square minus 5. Okay, so what is h and what is k? We can see that for h, this minus means we simply take the opposite. So h is going to be the opposite of positive 1, which is negative 1. And then k is going to be negative 5. Alright? So note for h, you do the opposite of the number grouped with the x. For k, you simply take the constant that's added to the squared quantity, added or subtracted from the squared quantity. Okay, so with that in mind, we can now write down what our vertex is. Since we know what h and k are, our vertex is going to be negative 1, comma, negative 5. Alright, let's move on to the b part. We're to find the opening. The opening of our parabolic function is basically determined by the sign of a. Alright, the sign of a. Is a positive or is it negative? Now in this particular case, we have a situation where a is negative. So what does that mean? It tells us that y, the function y, opens downwards. Okay, it opens downwards, a downward opening parabolic curve. Why is that? Because a, which is negative 3, is less than 0. Okay, if you do not want to deal with the inequality notation, you can also say a is negative. Alright, so if a is negative, that's sufficient to conclude that the opening of the related parabolic curve is downward. Next thing we need to find is the extreme value and location. Alright, so to do this, we're going to make use of the vertex again. So let's go ahead and determine what the extreme value and location are. So the question, first of all, is what is the nature of the extreme of this parabolic curve? If it opens downwards, the parabola has a peak, which is known as the maximum. Okay, so let's put a side note here. Something to keep in mind is that if we have, if a is less than 0, we have a sad scenario, a downward facing parabola as indicated here, which means we have a maximum as the extrema. Okay, if a were positive, we have an upward opening parabola, which means that our extrema will be a minimum. Okay. All right. So let's go ahead and write down what our extrema is and what the value is. Also, in this case, we have a maximum because it's downward opening. Maximum value of the y-coordinate of the vertex, y equals -5 at x equals the x-coordinate of the vertex, -1. Okay, so the vertex tells us the extrema value and the location. All right, now let's move on to the next part. We're now going to look for the axis of symmetry. The axis of symmetry is determined by simply looking at what the x-coordinate of the vertex is. Okay, so what's the x-coordinate of the vertex? The x-coordinate of the vertex is -1, so our axis of symmetry is the equation of the line x equals -1. Alright, next, our shifts. What kind of translations on the parent quadratic curve will result in the graph of this function here? We're going to use our h and k again. So our shifts are going to be just following exactly what the vertex tells you. You're going to shift 1 unit to the left and 5 units down. That will place the vertex in quadrant number 3. Okay, now we're going to generate a table of values to help us to graph our curve. So what we're going to do is we're going to pick a point before and a point after the vertex. Alrighty, so let's go ahead and set this up. So on the first column, we're going to have the x's. So the vertex is -1, comma -5. So the x value is -1. We want to find out what y will be for this given x values. So the function is -3 times the quantity x plus 1 square minus 5. Let me check it again to make sure. Okay, looks good. Alright, now what we're going to do is determine the output values with these specific x values that we select. Well, what are they? We're going to pick a number before -1, which is -2, and a number after it, which is 0. Okay, plug it in here. So we have y of -2. We're going to plug in -2 into this function. Forgot my -5 here. So we're going to have -3 times -2 plus 1 square minus 5. Now we're going to use the order of operations. Please excuse my dear Aunt Sally to simplify this. We have -3 times -2 plus 1 is -1 square minus 5. -1 square is just 1, so we have -3 times 1 minus 5, and that's just negative 3 minus 5, which is negative 8. Okay, so that is what our output value will be when x is equal to negative 2. Alright, so now the question is, what is our output value going to be when x is negative 1? Okay, so let's put that y is going to be negative 8. When x is negative 1, using the vertex, we automatically know that this should be negative 5. So we don't have to bother doing any work here since the vertex already showed us what it's going to be. So put a smiley face. Now, this is where the check happens. When I put in 0, 4 into the function, since negative 1 is the axis of symmetry, the output for 0 and negative 2, the points about the vertex, should be exactly the same, or else there is a mistake somewhere. So we're going to look for y of 0, which is negative 3, times 0 plus 1 square minus 5. That gives us negative 3 times 1 square minus 5, which is negative 3 times 1 is just negative 3 minus 5. Final answer is negative 8, and it matches perfectly, so everything is good. Okay, we also have to look for our y-intercept. Our y-intercept is what we'll get when x is equal to 0. So we have a coincidence here where our y-intercept happens to be one of the points, so we don't have to bother with that. Alright, let's go ahead and finish this off by sketching the graph of the parabola with a given equation using our points as a guide. So we are located negative 1, negative 5 is in quadrant 3. So set it up. Let's calibrate our axis. So we're going to go, let's look at the range on the y. Y goes from negative 5 to negative 8. So let's calibrate the x-axis. We have 1, 2, 3, 4, 5, 6, 7, 8. And then our x's go from 0 all the way to negative 2. 1, 2. And that's 0 right there. Alright, let's start by graphing the vertex. The vertex is at negative 1, negative 5. So we have negative 1 right here, and negative 5. 1, 2, 3, 4, 5. So there goes the vertex. Next point is negative 2, negative 8. So negative 2, 5, 6, 7, 8. Negative 8 will be right here. This is negative 2. And then 0 also takes us to negative 8. Do you see the parabola? This is exactly what it looks like. It's connected dots, opening downwards, like that. Let's do that other part again. Let's curve it a little bit to make it straight, and then you go through that that line. Alright, so there goes your parabolic function. Alright, now what we're going to do is we're going to go ahead and label this completely. Let's start off by graphing our axis of symmetry. This line right here, this line, let's put it in black. The equation of this line is x equals negative 1, right? This is our axis of symmetry. It basically represents the line that breaks the graph into two identical parts. X equals negative 1. And then this point right here is our vertex. Okay, so our vertex, we talked about that before. Our vertex is negative 1, negative 5. And then we have the maximum value. Let's change colors here. Let's make it green. Alright, so if we trace our vertex to the y-axis, it tells us exactly what the maximum value is. So our y-max in this particular case, y-max is this value right here, which is equal to negative 5. Okay, that agrees with what we had earlier. So we have everything labeled. Now let's just go ahead and state our domain and range while we're at it. So the domain here is going to be the width of the graph. So it basically goes from negative infinity to infinity, since it goes to the left forever and to the right forever. If we project this graph on the x-axis, that's what our width will be. And then the range, this graph goes down forever, but it goes as high as negative 5. So using interval notation, we can say the graph goes from negative infinity all the way to negative 5 included. Alright, so there you have it. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful in your studies of quadratic functions, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments about the contents of this presentation, just place it in the comments section below, and we'll be more than glad to support you. Don't forget to subscribe to our channel for updates to other tutorials such as this. More clips can be found on math.serve.com. Thanks again for watching, and have a wonderful day. Goodbye.